Well, good evening, my dears. Today we are going to talk about solving systems of linear inequalities by graphing. Please take out your notes as we're going through this. You are going to be titling this Graphing Systems of Linear Inequalities. Your essential question that you're going to come back to at the end of this video is, how do I know the solution to a system of linear inequalities? Your two vocabulary terms look very familiar because they are the same-ish as before. Go ahead and jot these down and pause your video. All right, the big idea that you need to be walking away from today is this visualization right here of what graphing systems of linear inequalities looks like. Go ahead and pause your video and write down our 2 steps that we go through when solving systems of linear inequalities by graphing. Also, it's important that you write down this visual because it will help you see, but don't get too nitpicky about it. Just sketch it. Awesome. Thank you for pausing that video of yours. We're going to start off with our examples easy and we're going to gradually get harder. So tell whether the ordered pair is a solution of the linear inequality. What we need to do is we need to plug in our ordered pair into each. There's 2, so I need to do 2 plug-ins and see if the statement stays true. Y less than 5 is 5 less than 5, and y greater than is 5 greater than x negative 1 minus 4. Is 5 less than 5? Nope. Is 5 greater than negative 5? Yes, but since one of these is not true, this is not a solution. All right, number 2, go ahead and pause your video and try number 2 and resume it when you're ready to check your answer. Thank you for pausing your video. What we're going to do is we plug in our solution in the 2. So is negative 1 less than equal to negative 2 times 0 plus 5? Is negative 1 less than equal to 5? The answer is yes. All right, the second one is negative 1 less than equal to 0 plus 3. Negative 1 less than 3, the answer is yes, so this is a solution, so yes. All right, now let's talk about how do we graph the systems of linear inequalities. We kept talking about this y equals mx plus b slope-intercept form is the easiest way to graph, and we're going to continue working with that. And our third example, we have the second equation is not in that perfect form, but we'll talk about how to get it there very quickly. All right, let's go through and graph our first inequality. I'm going to use purple so we can see the difference. Y equals m, the slope is negative 1, and our intercept is positive 4. So positive 4, 1, 2, 3, 4, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Okay, also I can go left 1, up 1. All right, we have our line. Is it filled in? Yes, because there's this equal sign underneath. Now, which way do we shade? Where y is greater, shading up where y is greater. All right, x plus y less than 0. Not our best form. However, if we take away x from both sides, we'll have y equals mx plus b. Our new equation is y less than negative x. Ooh, can't see that's a negative. Okay, no intercept, so that means our intercept is 0. Our slope is negative 1, so we'll go down 1 over 1, down 1 over 1, down 1 over 1. Interesting. Now we need to shade in the direction. Oops, sorry, this is a dotted line. Dotted line, let me go back through and dot this line. Dotted line, because it's not equal to. Dotted line. And which way do we shade? We shade where y is less than. Y is less than. Interesting. This is one of our special ones because it does not have a intersection between the two filled in. Let's go ahead and go to example 4. All right, y equals mx plus b. Our slope is 2, and our intercept is negative 3. So 1, 2, 3, negative 3, up 2, 1, 2, over 1, up 2, over 1, up 2, over 1. All right, it's a dotted line because it doesn't say equal to. Ooh, I hope your line looks better than mine. All right, and next one, I'm going to do it in a different color. Slope is a half, intercept is 1. Starting off at 1, we'll go up 1 over 2. Up 1 over 2. Up 1 over 2. All right, and this is filled in because it says equal to. Now I'm going to go back through and talk about shading so we can figure out which way. Our first one, y is greater than, so I'm going to shade to the greater y side of my blue one. In the purple one, y is also greater than, so I'm going to shade to the greater side. Where the two colors collide is where your answer is. I'm going to shade that green. Here's all our solutions of the system. All the solutions make this weird shape. All right, I would like you to try example 5. Pause your video and come back and we'll talk about the answer. Thank you for pausing your video. I'm going to go very quickly through this. So if you have to replay this, replay it. All right, changing this into y equals mx plus b, y is less than 2x plus 4. Changing this one to y equals mx plus b, y is greater than negative 2x plus 4. All right, graph, slope 2, intercept 4, 1, 2, 3, 4, down, up 2 over 1, or down 2 to the left 1, 1, 2, left 1, 1, left 1. All right, this is going to be a dotted line, and we're going to shade to the y is less than, so we're going to shade down. All right, negative 2x, 4, 4, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1. All right, and this is also going to be a dotted, and now we're going to shade where the y is greater than. Y is greater than here. Okay, where do they collide? They collide right here in our equations, inequalities. All right, let's go through this with making the equations now. All right, let's go ahead and write the inequalities from the graphs. Well, first off, we need to note that both of these, oh, green's a horrible color to write with, both of these are dotted. Both of these are dotted, so that tells us we're not using any equal sign. This first equation has the intercept of 2, so 2 plus, and a slope of down 1 over 1. So slope is a down 1, negative 1 over 1. So negative x, and we're shading down to the y's. So y has to be less than negative x plus 2. All right, let's talk about our second one. X is always going to be 3, and we shaded to the negative side of it, so x has to be less than 3. All right, I want you to try number 7. Pause your video and then resume it. Thank you for pausing your video. I'm going to call this one line 1 and this one line 2. They're both solid, so we know they have to be equal to. All right, our intercept for line 1 is 1, 2, 3, negative 3, and we go up 1, 2 over 1, up 2 over 1 x, and we shaded for this line, we shaded this direction, knowing we're shading down, so y has to be less than. Line 2, our intercept is at 1, so plus 1, and we went down 1 over 2, down 1 over 2x, and y we shaded for this one. I'm going to choose blue to show you. For this one, we shaded this direction because it collided here. So y has to be greater than or equal to. Both of these are equal to, so make sure you include that. Go through and answer your essential question now. How do I know the solution to a system of linear inequalities? I should have put solutions because there's more than one solution. They cross each other more than one ordered pair. Go ahead and answer, how do I know the solutions to a system of linear inequalities? And take the checkpoint 4.5 under materials. Have a good night, guys. See you tomorrow. Bye.